Hello. This presentation introduces you to new equipment installed in November 80585, a 1976 Cessna 172M airplane. In 2023, the airplane was refurbished, including new plexiglass, paint, interior, and a digital instrument panel that meets FAA technically advanced aircraft requirements. This presentation should provide you a good understanding of equipment operation. Like anything else in aviation, gaining and maintaining proficiency is going to take self-study and practice. All the references you need are available in electronic form online or by email. Here is our TAA syllabus, intended for somebody transitioning from steam gauge to glass. The conclusion of the training would result in a TAA endorsement in the pilot logbook for the purposes of documenting TAA training. Here is the equipment installed in November 80858. It's a clean airplane with a modern, customized panel that meets FAA technically advanced aircraft equipment requirements. Here is the G3 Touch Primary Flight Display PFD. G3X limitations are found in the Flight Manual Supplement. The G3X must use FAA-approved software version 8 or later. For IFR operations, an external certified IFR navigation source is required. In this case, the GTN 650 is used. The own ship on the moving map display must not be used as the primary or sole means of navigation. Traffic display and safe taxi are not to be used as the sole basis for aircraft maneuvering. Refer to the POH, not the glide range ring, to determine gliding distance. Consult the POH for weight and balance computation. Do not fly the airplane when the service required advisory appears. November 80858 is equipped and certified for VFR day, night, and IFR operations. On the bevel at the bottom of the G3X, we have two knobs, bottom left and bottom right. Then we have the nearest, direct to, menu, and back buttons. The nearest and direct to buttons are not used because we use the nearest and direct to buttons on the GTN 650 for navigation. The control knobs on the bottom left and right are indicated by the two red arrows, and I've expanded the legend that tells you what each does. As you page through different settings on the G3X, the legend will change accordingly and enunciate what each of the buttons do. Note the split screen selector in the upper right-hand corner of the G3X. This is how you toggle between full screen and split screen. An external GTN 650 navigator feeds the G3X. A magnetometer feeds the Attitude Heading Reference System, AHRS. OAT, PDOT, and static sensors feed the air data computer. The AHRS and air data computer feed the ADAHRS, the Air Data Attitude Heading Reference System that feeds the G3X. Engine data is shown on the JPI EDM 900 and is not fed to the G3X. This is the PFD in full screen mode. On top we have the attitude indicator. The left side is the airspeed tape. Right side are the altimeter and vertical speed tapes. Symbology is very similar to what you may have seen on the G5. On the bottom is the horizontal situation indicator, HSI. Bottom left and bottom right are insets, which are easily changed in the PFD options page. To bring up the PFD options page, place your finger or thumb on the HSI, and the PFD options page will appear. The PFD options page is where you select the G3X navigation CDI source, inset windows, bearing pointers, and barometric alerting minimums. Here is the HSI with bearing pointers. Bearing pointer 1, best airport, is a single blue arrow pointing to bearing 330. Bearing pointer number 2, set to nearest airport, is a double blue arrow pointing to bearing 235. Bearing 1 information window and bearing 2 information window will show the identifier and distance for the respective bearing pointer. Back on the PFD options page, we can set barometric altitude awareness enunciation. After loading the approach, we can set the minimums here. If a different approach is then loaded, we have to update the minimums for that approach. When the airplane arrives at minimum descent altitude or decision altitude, the G3X will enunciate minimums, minimums. After setting the barometric altitude awareness on the PFD options page, a barometric minimum bug will appear on the altitude tape, and a barometric minimum box will appear in the upper right quadrant of the HSI. The upper red arrow points to the split screen selector. This allows you to toggle between full screen and split screen mode. The knob in the lower right-hand corner allows you to scroll through the chapters and the pages within those chapters. Here is the low altitude en route IFR chart shown in split screen mode. The G3X incorporates a crew alerting message system, or CAS message. These are pre-programmed messages that can appear when the criteria for display is reached. An example of a CAS message is displayed here by the HSI. Synthetic vision is displayed by default. The forward-looking view shows terrain and obstacles. The zero pitch line is the horizon. The flight path pointer shows the airplane's trajectory. Pathways, the magenta boxes, are linked to the flight director selection on the AFCS mode control panel. The G3X can also display airport signs, traffic based on threat, runway, and ground proximity alerts. The G3X shows the true airspeed, top of the airspeed tape, and current wind displayed in the upper left corner of the horizontal situation indicator. When the aircraft is landed, the navigation map automatically zooms in to display the Safe Taxi diagram. Safe Taxi feature can be seen on the map page and the waypoint page. When viewing at ranges close enough to show the airport detail, the map will reveal taxiways, hotspots, airport landmarks, buildings, and control tower. The G5 primary flight display is a backup instrument for the G3X. It interfaces with the autopilot, provides course guidance and glide path. The backup battery provides 4 hours of operation. The GFC 500 autopilot is controlled by the GMC 507 Automatic Flight Control Systems mode control panel. It provides autopilot and flight director mode selection keys and a wheel for convenient adjustment of the pitch, airspeed, and vertical speed references. Electronic Stability and Protection, ESP, runs in background. ESP monitors the aircraft and provides control input feedback at potentially unsafe attitudes and/or airspeeds. If enabled, with the autopilot off, ESP automatically arms above 500 feet AGL and disarms below 200 feet AGL. The autopilot and flight director are two different features controlled by the AFCS mode select panel. The flight director is the brain and the autopilot the muscle. By engaging the autopilot and flight director, you are telling the servo motors to take over and move the control surfaces based on flight director guidance. A review of the AFCS mode control panel begins with the yaw damp button. The yaw damp button is non-functional because the Skyhawk does not have a yaw damp servo. The other buttons, except for 2, are momentary action on-off switches. The remaining 2, flight director and level, are lock push button switches. The flight director button turns on the flight director. If you turn on the flight director and the autopilot, then you cannot turn off the flight director. Remember, the autopilot requires the flight director to function. The other button is the level button in blue. If you're disoriented or overtasked, you press the level button. This commands 0 roll and 0 pitch. To get out of level mode is easy. Just engage another mode or disconnect the autopilot. The autopilot disconnect switch is located on the control yoke. Push it once and the autopilot disengages with an oral alert sound. Push it again and the oral alert stops. Looking at the AFCS mode control panel, lateral modes are on the left and vertical modes are on the right. The knob on the left is used to select heading. The one on the right is used to select altitude. Pushing either of these 2 knobs will sync heading or altitude. Additionally, on the right side, you'll see a wheel that rolls up or down to set either vertical speed or airspeed. For example, in vertical speed mode, if you were descending at 100 foot per minute and wanted to increase the descent rate to 800 foot per minute, you would roll the window up 3 clicks to descend at 800 foot per minute. Think of it like the elevator trim control. Roll forward for nose down, roll aft for nose up. The approach button in the lateral section is kind of a hybrid button because it can be both a lateral mode and a vertical mode. While tracking in lateral mode, it can capture a glide slope and fly an approach down to minimums. There is an autopilot limitation here. The autopilot must be disengaged by 200 feet. The flight director. The yellow features are the plane itself, the left wing, the right wing, and the nose in the middle. The magenta figure V are the flight director command bars. Autopilot and flight director. The yellow symbol is always there, just like any other attitude indicator. When you turn on the flight director, the magenta command bars appear. When the command bars are hollow, the flight director is on and the autopilot is off. When the command bars are solid, the flight director and the autopilot are on. When the autopilot and flight director are being used, the flight director directs the flight. The direction is displayed by the command bars. If you tuck the yellow chevron inside the magenta chevron and keep it there, it will direct you where to fly both laterally and vertically based on what you selected on the AFCS control panel. For a moment, let's assume you are in heading mode and you move the heading bug to the right. The flight director would command a roll to the right. The AFCS status box displays autopilot and flight director modes. When using the autopilot, you must include the AFCS status box in your scan to confirm AFCS mode selection. Whenever you make a change on the AFCS mode control panel, you must verify selected mode enunciation in the status box. Green is active or engaged, and white means armed. AFCS status box enunciations. Green means active, white, armed, and yellow, disengaged. When you make an input on the AFCS mode control panel, always verify active and armed mode. The GTN 650XI is a GPS, nav, comm, multifunctional display, all rolled into a single box. Those who have flown November 1339 or 4, or the ULSIM, are likely familiar with the GTN 650. The GTN650XI has increased processor speed and Smart Glide. Touchscreen swipes left and right, no up and down controls. Transponder code is not displayed, and in its place is an ETE box. The G3X uses the GTN650XI as its external IFR certified GPS navigator. The G3X uses the GTN650XI as its COM1 and NAV1 radios. Traffic and weather from the GTX 345 transponder are displayed on the GTN650XI and G3X. When the unit powers up, it performs a database currency and receiver autonomous integrity monitoring check, as well as CDI and VDI checks. You will note 4 controls on the front panel. Upper left is the power volume control. Upper right is the home button that allows you to return to the home screen. On the right side is the Direct To button. On the lower right side is the multifunction COM nav tuner control. The default nav page shows the CDI selector and map buttons. The CDI button allows you to toggle between GPS and VLOC navigation sources. The map button allows you to switch to the map page. On the map page, you can use the back button to toggle back to the default nav page. In utilities, you can use the fuel planning capability to validate your in-flight fuel consumption and fuel state. In the event of an engine failure or partial power loss, Smart Glide allows you to quickly locate and plot a direct course to the most suitable airport within glide range, avoiding terrain and obstacles along the way. Smart Glide must be activated manually. A review of the GNC 255A COM nav radio begins on the left side of the control panel. The COM and nav volume control knobs reside here. Press and release the COM knob and it overrides the squelch. The letters SQ will appear in the display. Press and release the nav knob and you can hear the Morse code of the active nav aid. The monitor key, the MON key, allows you to listen to the standby frequency. The C/N key allows you to toggle the display between COM and nav frequencies. The OBS key allows you to display the current OBS setting with the graphic CDI in the display. The T/F is the to from key and it toggles the bearing to and from the active VOR. The function key displays system configuration, timer, and ICS configuration. The CLR button, the clear button, cancels entries and resets timers. The double arrow flip-flop key transfers active and standby frequencies. And if you press and hold the flip-flop key for 3 seconds, the emergency frequency 121.5 will display in the active frequency. On the bottom right where it says tune, you have the outer and inner knobs which are used for tuning frequencies and data entry. The PMA 8000G is a fairly straightforward audio panel. The HRTF key, the head-related transfer function, uses spatial processing, allowing the COM1 radio to sound as if it's at the 10 o'clock position and the COM2 radio to sound as if it's at the 2 o'clock position. The play button allows the pilot to play back the last radio message. In the normal mode, the PMA 8000G gives priority to the pilot push-to-talk switch. If the co-pilot is transmitting and the pilot presses the PTT switch, the pilot's microphone will be heard over the selected transmitter. To activate split mode, push transmit 1 and 2 buttons at the same time. All 4 indicators will illuminate. In split mode, the pilot is on COM1, while the co-pilot is on COM2. In split mode, the intercom between pilot and co-pilot is off, as is the green ICS indicator. It is not possible to have the pilot on COM 2 and the co-pilot on COM 1 in split mode. Select either of the COM XMT buttons to exit the split mode. To connect a Bluetooth device to the audio panel, select PMA 8000G from the list on your Bluetooth device. When power is removed from the audio panel, the PMA 8000G is in fail-safe mode. In this mode, the pilot's headset is connected to COM 1 for transmit and receive, and connected to Input 1 for priority audio alerts. The fail-safe audio will only be heard in the left ear of a stereo headset. The GTX 345 is a Mode C and ADSB in and out transponder. Control keys are on, off, standby, altitude, VFR, and ident. The transponder turns on when the avionics master switch is placed in the on position. By default, altitude reporting is active. The VFR key sets 1200 code in the transponder. Other transponder codes are set using the number keys along the bottom of the panel. The function key lets you scroll flight ID, systems, and timers. The GTX 345 automatically provides ADSB traffic and weather to the GTN 650 and G3X. The JP Instruments EDM 900 is a certified digital replacement for analog gauges. The EDM 900 has preset alarm limits and cautionary ranges according to the POH. The user cannot change these. The remote annunciator light, placarded as Engine, provides notification that an alarm is present in the display. On power up, the pilot must confirm the remote annunciator light shows red and yellow, meaning it's functioning properly. A non-functioning remote annunciator light must be repaired before flight. 4 white operating buttons control EDM functions. These buttons change labels depending on the current state of the EDM. From left to right, the buttons are numbered 1, 2, 3, and 4. For EDM fuel calculations to be accurate, the pilot is required to enter the correct amount of fuel on board in the EDM. During pre-flight, always visually determine the fuel on board and enter that information in the EDM. On power up, the EDM will flash refuel ? If you didn't add any fuel, simply tap no to quit. If you filled both tanks, select 38 gallons. To adjust EDM fuel quantity to match the fuel on board, use the Add and Subtract feature. To show Hobbs and tach time, press and hold the second and third buttons simultaneously. Lean find and other features are described in the pilot's guide. Next steps in the syllabus are completing the flight manual supplement and pilot guide review, ALSIM EFIS, GTN 650 and autopilot familiarization, aircraft ground system training, flight instruction, and a TAA endorsement.